Hello, Kirtana, I'm audible.
Yes, sir.
Okay, so in the last class, I hope we did about uh, bio-Savart law we discussed, right? So in the last class, we had a discussion about this bio-Savart law. Basic formula discussion we had. Okay, today we'll be discussing more about it. Let's share the screen first. Yeah. Can you see the screen? Kirtana, can you see the screen?
Yes, sir.
Okay, so in the last class, we had discussion about bio-Savart law. I'll just write that back. Law. In this, I told you have a wire, the current is going as I. Okay. What you did, you kept a small distance dl, this was the angle. So due to this particular current section, what is the current at some distance r? Okay, this is what you calculated. So here the r was this. So yes, what we calculated the dv. This is what the current. What was the this equals to mu naught by 4 pi. Okay, and due to the previous formula, you can simply write this as I dl into r divided by r cubed. Okay, this is the formula we derived at the last, right? I hope it was clear to
Yes,
you.
sir.
Okay, so what we were discussing after this, that let's talk about what I did. Let's try to zoom it out. Okay, this portion, you had an electron moving downside. Okay, so you can simply say that here the current due to this at distance r. So the form, what is the formula due to this? The dp will be equals to, assume that this is the velocity. Okay. So you can say that mu naught by 4 pi. Okay. Current as it is, and whatever that distance, the velocity of the electron part into r. This is the formula of the current magnetic field due to the this particular charge, right?
Yes.
Okay. And you can, it's much better. What you can say that right now we are not sure how many electrons were there in this particular region, right? I just took an example of by taking single electron, but it's not necessary that there's only single electron. So we have something called number density. What is the number density? That is number of electrons divided by volume, right? How much volume we have. So you can say that if I multiply this electron with the total number of electrons, so you can say this will give me the total charge, motion with charge, right? And we know the formula is basically here we have to give the charge, okay? Have the charge. So from where I'm going to get the charge is equals to E total number. So here I can multiply N. This is number of electrons. But you know, number density is equals to number of electrons divided by volume. So I can say N is equals to number density multiplied by V. Understood this part till here? Like till this particular portion? Is it clear? Because I'm going to substitute this particular value of N, okay, which I'm going to put here, and then I will substitute over here. So let's see. So you can say this here it was supposed to be the charge q, okay, in this particular reason. Here the charge is nothing but e negative e, basically electron times of n, number of electrons in dl region. Okay, dl region we'll be studying it bit more, although that whatever we have studied so far is although fine, is equals to n divided by v, number density. Okay, If you could remember this formula we have studied in the previous electrostatics chapter, we were using the formula, right? I is equals to A N E V D, right? Here this was area, number density, electron, and the drift velocity.
Yes, sir.
Okay, so similar things. So you can see I can rewrite instead of this n because number density I want to be knowing because for a wire you don't know what is the number of electrons here. You know just the number density. Okay, you may know the number density. So this thing can be re-represented as E negative multiplied by the this number density, boulder number density multiplied by the volume. What is the volume? Again, the volume is very simple, right? This is a wire. Okay, what is the volume? The length dl multiplied by the r square, right? Because this is the area. So you can say dl multiplied by the area. That is what you can say. Okay. So I hope if you're clear with this thing, I'll try to remove all this. Let's keep them as it is. So you can now say q is equals to minus e times of n. Instead of v, I'll write dl. And here I can write it because q is a constant, like it's a scalar vector. So I will directly put the scalar values. Here you can write as pi r square. This is what you can write. Is it clear now? This small portion is dl, smaller length. Okay. I hope this might
Yes.
be clear. Uh, so we can actually simplify the thing and you can rewrite the same thing as q is equals to e negative. Instead of n, you can write the number density a times of dl, okay, the area. So just put it over here. So dv will come out as mu naught by 4 pi. Here q minus e, n number density, a dl, and that vd cross r by r cube. Clear? I hope it's clear for you, right? Any
Yes.
doubts so far?
No, sir.
No, right. Now let's simplify it okay, a little bit. Mu naught upon 4 pi. Now you know that Kirtana, this dl is a vector, right? Which is representing the direction, and this vd here I have written that is also representing the direction. If you see carefully, can I do one thing that this dl is actually representing the upper length, right? The total length in this direct. This was my portion I took. This dl is representing this part. My vd is basically the velocity of electron. So this is representing vd downside. If you see carefully, can I say that this dl basically the direction, this is nothing but dl magnitude multiplied by the v d vector. Can I say this unit vector basically negative basically because this is the magnitude and this is the direction. So opposite of that, this is moving in this direction. The opposite direction is this. Can I say that? So what I'm going to do is instead of this vd can be you can write as magnitude of vd multiplied by the dl vector magnitude. Okay, unit vector. So now you can say that this take this negative from here, okay, and put along with this vd. If you do this, you can write this. So you can say dl multi cross r divided by r cube and this e as it is, number density as it is, a as it is, and instead of dl you can write v. Is it clear now? Just a replacement, okay? Because
Yes.
directions were opposite. Okay, I had this parameter earlier. What I did is instead of this, what I did, I said this you are opposite of this. So what I did, whatever the I write the value of dl as its magnitude, the exact length that is dl, and the direction I wrote, its direction is v, right, which is downside. So what I said, direction is minus. Is it clear now? And this is what I did over here.
Yes, sir.
Okay, makes sense. And if you see carefully, I just wrote a formula little bit backside. What is A N E V D? You know that in a wire, if there's a current, Vd is nothing but the drift velocity of electron, which is attained by the particle itself, right? This
Yes, sir.
velocity is the particle. So can I say that it is A N E V D is nothing but the current itself? Because I just told you the current is nothing but A N E V D, right? Got it. We got the answer, right? This is another method of deriving this thing. Okay. I have given you two methods of derivation for the Biot Savart law. One is yesterday's method, one is today's method. Okay. So D L cross R. At the end of the day, you have ideally two formulas, but this is just a way of deriving the things. Okay. Direction. What is the direction? Direction is this. Okay. DL cross R. So let's discuss in a normal way. Assume this is the direction of current. Okay. This is a wire, and here you have a. This is the direction of current. Okay? So from here, you wanted to calculate current at this point. What you will say, you know that whenever you are going to take, you will take some length here, right, in this direction. So you will say that what is the direction of magnetic field here? That is dl. So dl cross r. It means you have to do, this is the radius r in this direction. You have to do cross product from here to here. So you know the easier way, right? Take your hand. Okay, basically take your hand. Face your main hand. Okay, four fingers or five fingers towards the first vector. You can say this is I, and try to curl that towards this vector. Wherever your thumb is pointing, okay, wherever your thumb is pointing, that is the direction of magnetic field. Is it clear now? So assume that this is, and one more thing, whenever you are keeping your front along with first vector, the face of your hand should be pointing towards the other vector, okay? Because you can keep your hand in this way also, and face is pointing that side. No, that should not be the thing. If you are going to keep it like this, it is pointing downside and your face is pointing here. Now you have to curl your fingers the moment wherever your this thumb is pointing, that is the direction of the current. So if you try to do by your hand, you will see that here the direction is coming out to be uh, inwards to the plane. Okay, inside the plane it is coming out. So this is r vector, dl vector, small portion inside. Okay? If you take the same thing over here, here it will be outside. Is it clear now?
Yes, sir.
Okay, makes sense. So yeah, let's move next. Now assume that, let's talk about a concept. Assume this is a current carrying wire. Okay? This is a current carrying wire. This is a zoomed portion of a current carrying wire. Now assume that some electrons are there which is coming downside. Okay. So yeah, great. So this is the condition right now. Can you tell me, because I wanted to do, I have some extra problem. Can you tell me what will be the direction of current in this particular region and what will be the direction of current in this region? Direction of magnetic field, sorry. What is the direction of magnetic field in this region and this region? Kirtana, can you tell me the direction of the magnetic field in this region? Just remove it once. In this region and this region. I have given you two regions. You have to tell me magnetic field in this part and this part. Okay. Look, I will tell you one much more better way. When you have to do cross product of A to B, right? So what is the best way is assume you have two vectors A and B. Okay. Look, all methods are independent, so don't merge methods. So the method which I'm going to tell you, open your hand, thumb like this. Okay, complete hand like this. Now what you have to do, keep your hand, keep your thumb towards the first vector. Maybe assume this is the first vector. Okay, and all these palm in on a 90 degree. Basically, you are not supposed to, not necessary to be keep 90 degree. Okay, whatever I need has been removed. This kind of thing is there. Okay, so one vector is pointing in this direction, another vector is pointing, assume the palm direction. What you have to do, the face, wherever your hand is facing, that is the dot direction of your dot product. Okay, because you have to just keep this them straight. Okay, so that this thumb and these things fingers are in the same plane. Okay, then you can say this is one vector, this is the another vector, and the third vector is pointing towards this way. This is one method. Another method is using whatever I told you earlier, all your palms to facing towards another vector, fingers facing towards one vector, so thumb is pointing to that thing. These two methods are there. Okay, is it clear now? So now what you can do is simply go and keep your thumb over here. When you do this, what you can see, thumbs are pointing to this side, this is pointing to this side, and your face, your this face is pointing towards upside. Okay, hand of face of your hand is pointing toward upside. But if you see carefully, the formula was B is equals to B is directly proportional to Q times of V cross B, right? Here, if you see carefully, this is your velocity direction, this is R direction. So if you are doing this cross this, it means you should be getting the answer. But the problem is, whatever the direction from here you are getting, it will get negative because we are supposed to hear positive direction. Okay. So assume this gives you a downside direction, and due to this negative charge, you got a negative. It means the whole downward will become upward. Okay, that is the thing. So in this particular case, if you use any method on this charge, you should be getting upside, but due to this negative charge, it will become downside. Okay, here you will be getting downside, but due to positive negative charge, it will become upside. Okay, so here your magnetic field is going inside to the plane, inside of plane, and outside. Look, kids, now if you are not able to decide what is the direction of magnetic field in this particular chapter, so you won't be able to solve any problem. Okay? This chapter is all about the direction calculation, finding the directions and all. If you are not able to figure out the direction of these things, so you will never be able to solve the problems. Okay, so that's the thing. Yeah. So Kirtana, what do you think? We are making this magnetic field, that is fine. Do you think it is dependent upon the observer? Do you think this magnetic field actually depend upon the observer? Because this velocity is there, okay? When the object is moving, generally you can say if object is moving, the velocity of the object depends upon the observer, right? Because he starts moving, he will say more velocity. If he is moving this way, he will say less velocity. So what do you think in this case? The value of magnetic field, does it depend upon how your observer is moving or not? Just let me know this thing.
No, sir.
Why?
The velocity are in the same direction. Depends on the direction.
What it depends upon?
Direction.
What kind of direction it depends upon?
The direction of the velocity.
No, that is fine. You are talking about direction. I'm talking about the value.
The
So look, Kirtana, what I'm trying to say, assume you have an observer. He is moving downside with the same velocity VD. You know all the charges in the current in this wire, electrons are moving in VD, right? So because both have the same velocity, assume you have a plane, right? Another object is there. He is moving with V. You are also moving with V. So when you both were here, because you both have capability to move with V, so he will also reach here. You will also be reaching here. So what you will say that you were previously you were also with him. Here also you are with him. So what you will say that object is rest with respect to you. In this particular condition, the velocity here the velocity of electron with respect to you is going to be zero. But for magnetic field, what you want, it depends upon velocity, right? Because B is equals to mu naught by 4 pi Q times of V cross R. Okay. In simplification, we can remove this vector form right now, but so you can simply say some K. I'm calling this as K, Q V R by RQ. So here, because the velocity becomes zero, what do you think? Should it have some value or will it become zero?
it will become zero.
Okay. Just think of it. Okay, don't write like his answer. Just think of it. Just think of it, Kirtana.
Sir, if we take only magnitude, it becomes zero. Like if we take a direction, it is not zero. So
Yeah, Kirtana, have you figure out the thing? So things have been removed. I'll just make it fast. So this was the small condition. The condition was basically electron, electron, and electron. Okay? Downside, downside, downside. You know the velocity. Right? Okay. These electrons were there. What I told is, uh, when you started observing, you said, I am keeping a particle. Okay, I have started moving with the same velocity as of the electron. Now my question is, what do you think? Will this magnetic field, the value of magnetic field is going to dependent upon the velocity, because what I just framed you is the velocity due to you, due to observer, maybe this is the observer O, okay, the velocity of electron due to observer is zero, because both have same velocity. So for this object, if he assume that he is in the train, assume this is an electron, he is moving with velocity vd. He is inside a train. There's an observer who is observing, and he is sitting inside some train. Okay, maybe here. This train is also moving with vd. So whenever he is going to see him, he will say they both are the same point. For him, this observer is on the zero. So what he will say, this is an electron. He will try to calculate the velocity. If he is going to calculate a velocity due to this particle, what he will say that he will put the formula and he will say velocity is equal to zero. He will put the value of velocity zero because he is able to see you every time. So for him, you are at the zero. So what do you think? What should be the thing? Okay, why this condition is arriving? What do you think? Is it correct or something we are missing out? Please look at this and let me know what will it do. Does this value of magnetic field depend upon this frame of reference or not?
velocity is a vector, so it depends on the direction or
It depends upon
not
direction,
only
that
the
is fine.
magnet.
But I am just talking about this particular magnitude condition. Okay? Let's talk about the magnitude. Right now, we are not concerned whether it is going inside or outside. Okay? We are talking about the magnitude value because this K, Q, V, R, pi, R, Q, right? Here you can remove this R also, just R is more than fine. Because here the velocity is coming out zero. If he is going to put the value zero, for him it is zero. But I know because another person who is sitting on the ground, for him the velocity, his velocity is zero. His velocity is zero. Okay, on the ground, the person from a ground, he will say his velocity is zero. For him, the velocity of electron with respect to the person on ground is nothing but velocity of electron minus zero. So that is v. Okay, so for he will say that the electron is moving with this velocity. Okay, when he is going to apply, he will say q, uh, v has a velocity vd, and whatever the distance, he will say, okay, this particle is moving, but this guy will say the particle is not moving. It does not have any electric field, magnetic field. So how we should identify this thing? Why this error is coming out? Any idea? Just try to figure out which thing we are missing right now. Why we are getting a small incorrect result?
Due to the observer.
Due to observer. No, it's not a problem of observer, right? Where we are missing in this problem? Yeah, Kirtana, have you got the idea about it? Look, I don't know why. Did you understood what's the problem? Kirtana, have you understood what is the main problem over here? What I'm trying to ask you? Kirtana,
Yes.
yeah, so I'm saying, have you understood what is my query with you? What I'm trying to ask you?
Yes.
Okay, so can you explain me what I just asked you?
Like from one observer, the velocity of it is zero. From the other observer, it is giving a value. Why is
Yeah,
the difference?
yeah, why is the difference, right? Okay, let's see carefully. You understood about this guy, right? If you see carefully how these electrons are coming out, electrons are not even there. Okay, what happens is in conductor in a real we have complete atom. Right? When this electron from this atom, because there is a proton for this, okay, when this leaves, this becomes a proton. Makes sense. Assume that. Okay, I'll just try to erase everything and we'll come back to it. Okay? You understood why we were getting wrong. I will explain. Assume this electron is a result of this atom. Here I had an atom. From here, the electron come out, so this will become the positive. Here also the same, and here also the same. Because electrons move, atom remain on its the same position. Okay, makes sense. So, what is the main value? Why we are getting this value? It is result of the motion of the total charge, right? Total charge. So you can say K, Q, V, R divided by R Q. Basically, remove this R divided R square. Assume this is the point where I am trying to calculate. This is a particle V. What he is saying that he will say that there are two kind of charges. So there are two kind of charges. So when this guy is going and looking at this electron, he will say the velocity of electron with respect to observer is zero. So magnetic field at this point R, assume from here, this point R, okay, assume I'm talking about this whole section. So this R is nothing but K, this minus electron, the charge of this electron, and this V, velocity, which is downside. Okay? So assuming I'm calling this as positive, negative, and this I'm calling it as a positive. Okay? So this becomes negative. But this is zero because the net value downside with respect to him, that is zero. Keep it zero. R square, that is zero. Clear? This is one thing. But at the same time, because if I ask you what is the velocity of this positive charge, you will say velocity of positive charge with respect to observer is nothing but velocity of positive minus velocity of this observer. But if you see carefully, what is the velocity of positive charge? Nothing, zero. Minus what is the velocity of observer? Observer is moving downside with velocity v2. So this becomes negative v2. You got the answer as v2. Understood? Now the velocity v becomes positive charge e put e itself and v. Got the answer now. And the net result is nothing but b due to electron plus b due to electron plus b due to proton. Positive. E positive, e negative. Here it comes 0. Here it becomes Ke Vd divided by R square. Is it clear now? And now you understood the value. Okay. In previous cases, when okay, this is one thing. Due to this person who is on the ground, what he will say that the velocity of electron. For him, the velocity of electron is nothing but velocity of electron minus velocity on the ground. So he will say velocity of electron is Vd in the downside direction. So he will say negative Vd minus what is the velocity of ground? That is zero. So for him, the guy has velocity. So for him, the B is equals to the electron K minus E. The velocity is downside. So this is at the end of the day, he also got the same velocity. You can say the result we will see as completely same. This is the result. And what about the velocity due to proton? G velocity due to proton. Velocity of the proton is zero plus velocity, sorry, negative of velocity of V. Both are zero minus zero. So here velocity of proton is zero. If you add both V K Vd by R square plus zero. If you see carefully, what we are getting over here, same result at the end of the debate. We are getting the same result after both queries, right? So you can say that when you are looking with a different frame of reference, you have a different velocity. The velocity you have to consider velocity of both guys. So in one case, you might be getting velocity zero for him. Another case, you might be getting for him as zero. Is it clear now? Have you understood the concept clearly? Yes. Now, have you got the concept properly?
Yes, sir.
This was the main thing. Okay. I want to discuss about. We are done with this bio-Savart law. So let's talk about magnetic field due to straight line. Okay? So assume this is the whole thing, okay? This is the complete wire, and the wire is like this. Current I is there. If I ask you, Kirtana, can we calculate the current magnetic field due to this wire? You will say, sir, we are not sure how to calculate, but you know how to calculate magnetic field due to a very small portion of the wire, right? Okay, makes sense. So if I ask you to calculate magnetic field at some distance p, okay, this is the distance. So you will say, sir, we are not sure how to calculate, but you know how to calculate magnetic field due to very small portion of the wire, right? You know that is dB, right? So you will
Yes.
say, sir, this reason, so dl, okay, dl in this direction, and dl is in this direction. So here, this distance is nothing but r. So what you will say, dB is equals to what is the magnetic field due to this small portion, that is mu naught divided by 4 pi current dl cross dr divided by r. So mu naught by 4 pi I dlr cos theta. This is basically the angle between dl and r and sin theta. Here you have to keep sin theta. R. It means if you see that what is the angle between dl? If you see the this is one wire, this is another wire, so angle between them is zero, right? So here if you keep dv coming out to zero. Understood my point?
Yes.
Is it clear? Okay. If you wanted to calculate the value due to whole wire, what you can do is, I know this is due to very small portion. What you can do, complete B will coming out to be integrate, simply just integrate dV. So here the because the dV is coming out zero, you can simply go and say this integration is also going to be at zero. Okay, that is the for this particular part. We will try to calculate it for different position also. Now assume I am taking another case. Assume I have a long wire like this. Here the value is at P. Value is at P position. P position. Now this is the current. Now I wanted to calculate the current, the magnetic field due to this wire, straight wire, at some point here. Here, this is my point. So we will calculate the value afterwards. Just can we calculate the value? Can you calculate the direction at this point? Can you tell me the direction at this particular point? I'm calling this point as P. Kirtana, let me know the value, direction of this point. Value at this point.
Inwards.
Inwards, right? Makes sense. So it is going to be inwards. Put it in. So that is fine. Now our concern is to calculate the value. So this is point P. Here the value is inwards. Okay. You can say the total wire is from here to here. It is very similar. The concept is going to be very similar to the case where we calculate electric field due to a wire at some point, right? The same thing we are going to use it. So what you can say, you will be given that due to this charge, due to this wire, you have to calculate value at a distance r. Okay. You may be given this distance as r or a, anything it can be given. Some books write it as a, I will be writing it as r. R is the distance, okay, at which you are supposed to calculate the value. What you can do, okay, assume that the angle subtended this side is theta 1. Okay. Some books put the theta 1 here, theta 2 here, so accordingly you have to remember, okay, don't get confused with the things. Here it is theta 2. Okay, what I can do? You don't know how to calculate for the whole wire, but you know if I ask you what is the value due to this small portion, if I ask you what is the magnetic field due to this small portion at this point, you will say that magnetic field is coming out to be mu naught. sorry, mu naught by 4 pi. Okay. Current I as it is BL cross R divided by R. So makes sense, but I will put it in the form of mu naught by 4 pi I. What is the angle between them? You can say that DL R times of DL. So when you're going to keep it, this R get cancelled, which will become R square. And this angle is sine theta. What is this angle? Sine theta. Angle, this angle. Okay? You can call this angle very small, something phi. So this is basically your sine phi. Okay, this is what the thing we are going to do. Is it clear now?
Yes, sir.
But I don't need this angle. I really don't need this angle. What I can say that okay, if you see carefully, there is a one more difference. What is the difference is doesn't matter whether you are calculating due to this point, whether you are calculating due to this point. The value, the direction is always perpendicular inside. When you are calculating due to electric field, what happens is electric field due to this point is in this way, electric field due to this point is this way. So the net point actually dependent upon the point. Net direction was dependent. Here we don't have anything. We just need to integrate this thing and add it. In this case, we need to resolve it into two vectors, resolve this into two vectors. Okay, then we have to add this, subtract it, and so on for many parts. Okay, so here we had in that condition we had some value in either this and this. Here we only have magnetic field value in the direction perpendicular to the plane that is inside or outside it, only one direction. So here this is what I am going to do. So what I can do now? Any idea what I can do now? Okay. So let's do one thing.
Integrate.
Try to change it little bit. Okay? I will try to link change it little bit. So what is this small portion? Assume the total length is L. So I will call it X. Okay. X. The total this portion of length is X. Okay. From here we are going to, and we have taken dx. So when you take this out, we are going to get this value, right? And now assume that instead of phi, what is the value of phi? Phi is nothing but this angle, right?
Yes, sir.
Okay. Can I have a different value of phi? Can I use some different value of phi over here? Can I use some different value of phi over here? If you see carefully, my this value is changing, right? If I take this point, this angle will go like this. Okay, this go like this. I wanted to calculate some theta value, how my theta is changing. Okay? I wanted to get some parameter which dependent upon this theta value. Can we do that? Yes, we can. What is a sine theta? If you see carefully, if I ask you what is sine phi, sine phi is nothing but perpendicular upon B. No, not this. Sine phi is actually dependent upon perpendicular upon this, right? And what is that perpendicular divided by x square plus L square, right? Can you see this? Can you see this carefully?
Yes.
Okay, makes sense. So here, sorry, actually, this is not the thing I will I try to remove it. And here the R is not this. R is actually the length of this whole thing. Okay, yeah, quite missed a lot of things over here to cover up. Let's get it done. Did some calculations still. I'll just go there. Yeah. Okay, let's clear the thing little bit. Assume that my I'm instead of this portion, I'm now going to take this portion. Okay? I will make it clear a little bit about this. Assume that I have taken a very small portion, this point. and this point lies at some angle theta. Because current is going in this way, so dl I am going to take it this way. Call this is dx, small length dx. It is in this way I am going to take it. So if you see what is the angle, angle is this, right? And assume that here it is making angle phi. So if this is angle phi, what is this angle? Because angle between dl cross r when I am going to do, this is the angle I'm supposed to take, right? What is this angle? This is angle is basically, if you see carefully in the triangle, exterior angle property, if you know, if this is angle x and you wanted to calculate this, so this is nothing but summation of this. Okay, this angle is nothing but summation of these two angles. So here I have this angle is this, so it will come out as 90 plus 5. Okay? Because you wanted to calculate this, so it will be summation of the opposite angles. So opposite angle is 90 plus 5. Okay, this is supposed to be the value. Okay, so I'll try to remove it and go back and let's calculate the value. So dB coming out to be mu naught by 4 pi. Okay, I d dx cross, assume this is x, okay, this is distance is r, and this is a hypotenuse. Let's call this as L. Let's call this as L. So, divided by L is cube h. So when you put the value as a theta, what you can get is mu naught by 4 pi I dx divided by L square and sine 90 plus theta. Now, if you see carefully, this L is not important for me, right? I can remove this L. How I can remove this L? You know this phi, right? What is this phi? Can we say that cos phi is nothing but base, that is r divided by length L? From here, what I will say, this L is nothing but r divided by cos phi. This comes out as r times of secant phi, right? If you are clear with this thing, I am going to put the value. So this dB comes out equals to what happened? Mu naught by 4 pi I times of dx sine uh, 90 plus 5 divided by, instead of L square, what I can write? R square secant square. Okay, this is fine. So this is the thing I have got. Clear, clear now?
Yes.
Now, if you see what I wanted to do, I can integrate this phi. If either if it's up to you, you can do one thing, minus theta 1 to plus theta 2 you can do, or you can say that you started from this way, so it's up to you. If you wanted to take this side as minus or this side as minus, it's up to you. Okay, we wanted to integrate it, and what is my variable? That is 5. Okay, this is what we are going to do. So what I can say is, this is my theta dx, right? If you see carefully, this is the whole length, this is a small portion I took, this is the point. Can I say that this whole thing is nothing but, this dx is nothing but equals to this d theta times of this length L, right? And what is the length L? That is nothing but r of secant phi itself. Can I say this dx is equal to the whole thing?
Yes.
Can I say that, right? So remove remove the whole thing. Acha, one more thing. Let's do one thing. Remove all the constant outside. So if I do so, dB, this is constant, mu naught by 4 pi. I is also the constant. Keep it outside. Uh, yeah, I is actually the constant, right? Okay. I by r square is a constant, so I by r square outside. Integrate it, because if I integrate, if I'm going to get the value, right? What I'm left with inside, sine 90 plus theta, what it is? That is cos. Okay, so you can write this as cos phi. So it becomes cos phi dx divided by secant square phi. Clear?
Yes.
And you know we have just derived the value of this L as not something dx as we have derived it as what was the value we derived for dx?
R secant 5.
Yeah, r secant. Actually, skip out. Okay, let's not go in that way. I told you this is x, right? So what we can say that tan of this phi is nothing but perpendicular upon base, that is r. So if you differentiate it, you are going to get dx is equals to r times of secant square theta d theta d phi. Sorry, it should be d phi. So just put the value. When you put the value, if you integrate it completely, you are going to get completely that is equals to mu naught by 4 pi I divided by r square. Okay. From where to where you are going to integrate? You can say from either from minus theta 2 to theta 1. So call it as minus theta 1 to theta 2. Okay. And yes, instead of dx, what you can write the whole thing, this thing. So cos phi as it is, r you can keep it outside because this one r is there. Instead secant square phi d phi divided by secant square phi. If you see carefully, cancel, cancel. What are you left with? B mu naught, sorry, mu naught by 4 pi I by r integration of minus phi 1 to phi 2. Basically theta 1 to theta 2, you have cos phi to be integrated in the d. What is the integration final? You will be getting mu naught by 4 pi I by r. If you integrate this thing, what you are going to get? Sine of phi integration going from theta 2 divided by theta 1. So this whole thing is coming out to be mu naught by 4 pi I by r. Okay. Sine theta 2 minus sine theta. This is what the value you are going to get. Any doubts so far?
No.
Just look at this and let me know the value. Okay, sorry, it was minus 5, right? So here you have to keep minus value. And when you put the minus inside, this becomes positive. You should actually check the value before saying T1. So Kirtana, this is the derivation for this thing, okay? If you don't have any doubt, I will end the session by this. Clear? Kirtana, any query you have?
No, sir.
Kirtana, no query, right? So if you're clear with the thing, this is the formula for a wire. Okay. Now, if you wanted to do it for the infinite wire, what you can say that if the wire goes infinite, in that case, the theta 1, theta 2 will approach 0. Okay. For infinite wire, theta 1 and equals to theta 2 is equals to 90 degree. It will approach 90 degree. In that case, the B will come out as mu naught divided by 4 pi I by R 1 plus 1. That will be mu naught by 4 pi 2 I by R. And if informal, you can rewrite it as mu naught I by 2 pi R. Okay. It should be mu naught I by 2 pi. Okay. For semi-infinite, you can keep one as value, another as one. Understood this thing? What I meant by semi-infinite?
One end is at infinite, one is not at infinite.
Exactly. So this will be like this. I by R as it is 1 plus sine of the value. Yes. Whichever is the value that is not infinite. Okay. This where I have kept 1, you can assume this side, basically this thing. Okay. From here you are going to calculate this B at this point. So you will say this is the theta given to me. Another side you will say that is infinite. So for this you have kept it 90 degree. For this you have some value. Okay. That is the thing. So I hope it is clear now.
Yes.
Okay. So yeah. That's all for the today's class, Kirtana. I will end the session by this. Goodbye.